Hello friends and my dear students, I welcome you all to my channel. I hope you're all well and your studies are also going on well. This is part 4 video on the chapter of cubes and cube roots where I will solve the objective questions from the exercise 4D. I'm sorry, in the thumbnail it is written as 4H but it will be 4D from the textbook of author RS Aggarwal. If you have not watched the previous three parts videos on the chapter cubes and cube roots, I highly suggest that you watch those videos also to have a good understanding of the concepts of cubes and cube roots. So this video is part of the playlist CBSE Maths for Class 8 following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. So let's start solving the problems from exercise 4D. Okay, so I have the exercise 4D on the left hand side. These are MCQ problems. There are four choices A, B, C, D, and one choice is correct. We have to tick the correct choice, and there are only 10 questions. Okay, so let's start solving the problems. So the first problem says that which of the following numbers is a perfect cube. We have to check which number is a perfect cube. Let's see the choices one by one. 141. 141 is, if I do prime factorization, 141 will be it divides by 3. So 3 multiplied by 47, and 47 is a prime number. So this is the prime factorization. So definitely this is not a perfect cube. This is not a perfect cube because we cannot form all the prime factors are not part of triplets. Okay. Choice B is 294. 294. Let's do its prime factorization. 3 multiplied by 9, 98. This is equal to 3 multiplied by 49 multiplied by 2, and this is equal to 3 multiplied by 7 multiplied by 7 multiplied by 2. So this is also not a perfect cube because we cannot form any all the prime factors are not part of triplets. So this is not a perfect cube. C, 216. 216, let's divide, it will divide by 3. So 3 multiplied by 72, this is equal to 3 multiplied by 3 multiplied by 24. This is equal to 3 multiplied by 3 multiplied by 3 multiplied by 8, and we know that this is 3 cube multiplied by 8 is 2 cube. So this is 3 multiplied by 2 cube, that is 6 cube. So definitely this is a perfect cube. 216 is a cube of 6. So this is the correct choice. Since only one choice will be correct, so we need not check the options D. So answer is C. Let's do. So while I am solving the problem, you can pause the video and take screenshot of the solution for your future reference. Problem 2. Which of the following numbers is a perfect cube? Okay. So this time the numbers are a little big. So choice A, the number is 1152. Let's try to see what will be its prime factorization. Now you can do the prime factorization, but if you can do it orally, somehow find express it as factors of powers of factors, then also you can tell whether it is a perfect cube or not. Now I think this will divide by 4. Let's see, 4, 2, 8, uh, 8, 2, and 8. Okay, so this is equal to 4 multiplied by uh, 4 multiplied by 72. This is equal to 4 multiplied by 4 multiplied by 4. 72 can be factorized as 4 multiplied by 18. No, so this is not, definitely not a, uh, this is not a, 18 is not a perfect cube, but we have 4 cube multiplied by 18. 18. So definitely, if 1152 has to be a perfect cube, then this thing also has to be a cube of something. But 18 is 18 is not a cube, perfect cube number. So definitely, this is not a perfect cube. So let me quickly check once again if I did the factorization correctly or not. 4 multiplied by 4 to 8, 45. 8, 32, 8, okay, 4 multiplied by 4 multiplied by 7, 72, and okay. So A is not a perfect cube. B is 1331. 1331 is so some number. There are some numbers. Okay, one more thing. You must remember as much as possible all the squares and cubes, at least of all the single digit numbers, and also some of the two digit numbers. They're squares and cubes, like cube of 11, cube of 12, cube of 13, cube of 15, and their squares. If you can remember them, then it will be easier to solve some of the problems. So 1331, I guess it is a cube of 11. Let me see. I hope it will divide by 11. So 11, it will be, if I divide 1331 by 11, I get 1, and then 23, and then 21. Yes. So this is now 121 is 11 into 11. So this is 11 cube. So this is a perfect cube. That is 1331 is a cube of 11. So the correct choice definitely will be answer B. Now you can also, for the sake of practice, you can also check whether 2016 is a perfect cube or not. It is very essential, very important for you to be very familiar and very comfortable in finding the prime factorization of any given number. Now 2016, it will divide by 4. So this will be 4 multiplied by 504. This is equal to 4 multiplied by, it will again divide by 4. So 128. So this is equal to 4 multiplied by 4 multiplied by 4 multiplied by 32. And this is equal to 4 cube multiplied by, we know 32 is 16 into 2. 16 into 2. Okay. Now this is equal to 2 square. If you can convert the given number as a powers of some prime factors or some numbers, and all the powers are multiple of 3, then you can say that the number is a perfect cube. So 16 is 4 into 4, which is 2 to the power 4, and we have 2. So this is 2 square raised to the power 3 is 2 to the power 6 multiplied by 2 to the power 4 multiplied by 2. This is equal to 2 to the power 11. So this is not a perfect cube. 11 is not a multiple of 3. So not a perfect cube, as 11 is not multiple of 3. So one concept is that if you have an exponential term, let's say x is some non-zero rational number, any number, and we have a power m. If this is a perfect cube, this is a perfect cube, and let's say perfect cube. Well, a perfect cube means a natural number. Is perfect cube is a natural number for which there exists another natural number whose cube is that perfect number. So definitely in this x to the power m, we have to consider that x is a positive number. For positive x and m as some integer, x to the power m is a perfect cube if m, the power m, is a multiple of 3, is the multiple of 3 and x is a positive integer. If m is a multiple of 3, x to the power m is a perfect cube if m is a multiple of 3 and x is a positive integer, and also m is positive. M is positive. When m cannot be negative, then it will become if m becomes negative, then it will become 1 by a negative power means it's a reciprocal. So it will no longer be a natural number. A perfect cube is always a natural number for which there exists another natural number whose cube is that natural number. So, any exponential term of the form x to the power m, where m is a positive integer and x is a positive where both x and m are positive integer, then x to the power m will be a perfect cube if m is a multiple of 3. Okay. So C is definitely not a perfect cube, that is 2016, and the option D 739. Let's see whether now we have already found the answer. The answer is B, that is the perfect cube is 1331. But we are anyway checking the other options for the sake of practice. Now, prime factorization is a very important task that you have to always do for the chapters of square roots, cubes, and cube roots. So 739, the prime factorization will you divide by no, not divide by 7, no, 739. 729. 729 is a cube of 7. So 739 cannot be a perfect cube because 729 is equal to 7 cube. So 729 is a cube, perfect cube, which is 7 cube. So quite obviously, the next 739 cannot be a perfect cube. Okay. Let's do problem number 3. We have to evaluate cube root of 512. Now this is 512 is a very standard number. You must be familiar that the cube root of 512 is 8. That is, cube of 8 is 512. So this is we know that this is equal to, we know that 512 is 8 multiplied by 8 multiplied by 8. So the cube root of 8. So this is equal to cube root of 8 to the power 8 cube. So this is 8. So the correct choice is choice C. 4. We have to find cube root of 125 multiplied by 64. Now, if you have something like, if you have to evaluate cube root of x multiplied by y, and if you see both x and y are perfect cube, if both x and y are perfect cube, then you will express it as cube root of x multiplied by cube root of y. So in this example, problem 4, we can see both 125 is a cube root, is a perfect cube, and 64 is a perfect cube. So this will be equal to cube root of 125 multiplied by cube root of 64. And we know cube root of, we know 125 is 5 cube, and we know 64 is 4 cube. So this is equal to cube root of 5 cube is 5. That is, always remember that cube root of any number x cube, where x is some positive number, x cube is always equal to x. And we have 4. So this is equal to 20. Okay. So 20. So the correct choice is C. Let's do problem number 5. This is cube root of 64 divided by 343. So this is a cube root of a rational number. Again, we know that cube root of x by y, the rational number x by y, is equal to cube root of x divided by cube root of y. Now, if you see that in a cube root in a given expression, in the cube root of x by y, both x and y are perfect cube, then you will obviously rewrite it, express it as cube root of x divided by cube root of y. So we can see that 64 and 343, 64 is a perfect cube, that is, it is the cube of 4, and 343 is also a perfect cube, as it is the cube of, I guess, 7. So this will be, we will write it as cube root of 64 divided by cube root of 343, and this is cube root of 64 is 4 cube, and 343 is 7 cube. So this becomes 4 by 7. 4 by 7. So the correct choice is B. The correct choice is B. Okay. Let's do problem number 6. We have to find cube root of minus 512 divided by 729. Now, whenever you are given a rational number where it is a negative rational number inside a cube root, and the negative sign will not matter, because then a cube root of a negative number is also a negative number. You just have to see whether both the numerator, ignoring the sign of the rational number, whether both the numerator and the denominator are perfect cube or not. If they are, then you will rewrite this as cube root of the numerator divided by the cube root of the denominator. Since in this problem we know 512 is a perfect cube, that is, it is the cube of 8, and 729 is also a perfect cube, that is, it is the cube of 9. So we will write it as cube root of 512 divided by cube root of 729. So this is equal to cube root of 500 minus 512. We know it is the cube of minus 8. Minus 8. It is minus 512. That is why it is a cube of minus 8. We know that a cube of a negative number is a negative number. We know that minus x cube will be equal to negative of x cube. So minus 512, we know that 512 is a perfect cube, which is the cube of 8, and hence we can say that the minus 512 will be cube of minus 8, and the denominator we have 729 is the cube of 9. So this now becomes minus 8 by 9. Minus 8 by 9. So the answer is question number 6. The answer is minus 8 by 9. Answer is choice B. Answer is choice B. Okay. Question number 7. By what list number should 648 be multiplied to get a perfect cube? Okay. So we have to find the prime factorization of 648. 648. So let's do the prime factorization of 648. By what list number should, okay, let's start with the 2. This will be 3, 2, 4, again 2, 16, 2, again 2, 81. We know this is 3, 27, 3, 9, 3, 3. Okay. So 648 is prime factorization is 2 multiplied by 2 multiplied by 2 multiplied by 4 3s. So we see that we have to form how do we find the least number that need to be multiplied with the given number to make it a perfect cube. The steps are that we first do the prime factorization. We first find the prime factorization of the given number. Now next we form the triplets so that each triplet is triplets of equal factor, that is equal prime factor. That is, we group equal prime factors in a triplet. So there will be 2 triplets. First triplet is the 2 multiplied by 2 multiplied by 2, that is triplet of the factor 2, and the second will be also another triplet of factor prime factor 3, and we will have a single factor 3 left behind, which is not part of any triplet. Now, so the next step is that if you have watched the video where I have explained where I have discussed about how to check how to find the least number that need to be multiplied and or divided with a given number to make it a perfect cube. The steps was that in the first we find the prime factorization, then we form the triplets from the prime factors, and then we identify after forming the triplets, we identify all those factors which are not part of any triplet. In this example, this factor 3 is not part of any triplet, and if there are and we will merge all those factors which are not part of any triplet, so that the equal factors, we will merge all the factors which are not part of any triplet, so that the as a power or as having some power, that is if there are same factor multiple times which are not part of any triplet, we will merge them together as a power. So in this case, and those powers as per the notes, we have to identify all those we have to identify all those factors after forming the triplets that are not part of any triplet, and from all those in all those factors which are not part of any triplet, we will merge the equal factors as powers, and that power if I refer as x to the power n, where x will be some prime factor and m can only be 1 or 2. The power m can only be 1 and 2. So I have to identify all these terms, all these x to the power m's. So in this case, this will be only 3 to the power 1, because the only prime factor that is left behind which is not part of any triplet is 3. So 3 is 3 to the power 1. Now this, and then from all the x to the power m's that we have found in the last step, that is in this problem it was 3 to the power 1, we have to from all the x to the power m that has been found in the last step, we have to find the corresponding terms x to the power 3 minus m. From x to the power m, there could be multiple x to the power m's which are not part of any triplets. So from all those x to the power m's, we will find the corresponding value, that is x to the power 3 minus m. There could be a single x to the power 3 minus m, or there could be some multiple x to the power 3 minus m. So in this problem, the x to the power m, the only x to the power m was 3 to the power 1. So from 3 to the power 1, we have to find the value x to the power 3 minus m, which will be 3 to the power 3 minus 1, which is 3 square. Now the answer will be the product of all the x to the power 3 minus m values that has been found in the last step. So the least number to be multiplied for this problem will be equal to 3 square. Since in this problem there is only one such term, that is x to the power 3 minus m, we have only one such x to the power 3 minus m, which is 3 square. This is 9. So we have to multiply 648. The least number that need to be multiplied with 648 is 9 to make it a perfect cube. So the answer is choice C. Now, if the logic is not clear, let me explain it once more with an example. Let's say you have a number n, and its prime factorization, let's say, is 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 3, let's say multiplied by 4 multiplied by 7 and multiplied by 7. Let's say, I don't know what this number will be. Let's say there is some number n whose prime factorization is this. Now we are asked to find the least number that need to be multiplied with this number n to make it a perfect cube. So we have done the prime factorization. Now we will form the triplets from the prime factors, and we have the triplets as there will only be one triplet of equal factor, where the equal factor is 2, and all the other factors, they will not be part of any triplet. They will not be part of any triplet. So the next step will be to identify all those x to the power m. All those x to the power m, we have to find the x to the power m where x to the power m is not part of any triplet. How we will find x to the power m from the factors which are not part of the triplet? So we will consider all the factors. We will consider all the factors which in this problem, in this case, is this, all the factors which are not part of any triplet, and merge the equal in those factors, merge the equal factors as powers. So we will get the x to the power m terms which is not part of any triplet will be 3 square, 4 to the power 1, since we have 4, we have 1 4, and 7 square. So for this problem, in this example, there are 3 such x to the power m which are not part of any triplet. That is, all the factors that are not part of any triplet, from all those factors, we have created x to the power m, that is by merging the similar factors as their power. So there was 2 3's, so 3 into 3 is 3 square. There was 1 4, so 4 to the power 1, and there was 2 7, so 7 square. So these are the x to the power m terms. That is, as per my notes, if you if as per my notes, the x to the power m terms are the terms which are not part of any triplet, and how x to the power m terms are being formed. You consider all the factors which are not part of the triplet, and from all those factors you merge the equal factors as power. So we have, for this example, 3 square, 4 to the power 1, and 7 square. Now from these terms of x to the power m terms, we will have to find the we have to compute the corresponding x to the power 3 minus m terms. For all these three terms, we have to find the corresponding x to the power 3 minus m terms. That is 3 to the power 3 minus 2, 4 to the power 3 minus 1, and 7 to the power 3 minus 2, which is basically 3 and 4 square and 7. So these are the 3 and 4 square and 7 are the x to the power 3 minus m terms. So the final result answer will be the least number that need to be multiplied with this number n to make it a perfect cube is the product of all the x to the power 3 minus m terms. That is 3 multiplied by 4 square multiplied by 7 will be the least number that need to be multiplied with this number n to make it a perfect cube. Now, if you are not very comfortable with this x to the power m and x to the power 3 minus m terms, this is then you can also do it from the common sense that from all the factors which are not part of any triplets, you have to consider multiplying with factors that will form a triplet. So we have 3 and 3. We have two 3's. So if I multiply the n with another 3, then the 3 there will be 3 3's. So it will form a triplet. Similarly, we have 1 4. So I need to multiply with 4 into 4. I have to multiply this n 4 twice. That is 4 into 4. Then it will form a triplet. Similarly, we have 7 into 7. I need to multiply n with 7 so that the 7 into 7 into 7 forms a triplet. Hence, the least number to be multiplied to make n a perfect cube will be 3 into 4 square into 7. Okay. Let's do problem number 8. 8 is by what least number should 1536 be divided to get a perfect cube. Okay. So the number given is 1536. So let's first find the prime factorization of 1536. Let's start with 2. We have 7, we have 6 and 8, and then we have 2, 3, 8, 4, and then we have 2, 1, 9, 2, and then 2. Okay. So the least number okay. So for the question 7, the least number to be multiplied was 9. Okay. Answer C. Okay, fine. Let's do problem number 8. Okay. So 1536, the prime factorization we are doing, this is 96. This is 48, and this is 24, and this is 12, and this is 2, 6, and this is 2, 3. So we can see how many 2's are there. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 2 to the power 9 because there are the 2 is coming in the prime factorization, the factor 2 is coming 9 times, and we have 3. Okay. Now 2 to the power 9 2 to the power 9 is the power 9 is a multiple of 3. So this is 2 to the power 3 and cube. So we can so from this we can see that 1536 is so this is 8 cube multiplied by 3. Now what should we multiply, what should we divide, what is the least number that we should divide 1536 to make it a perfect cube? The only factor which is not part of any triplet is the factor 3. So if we can somehow eliminate 3, that is, if you divide the number 1536 by 3, then it will become 8 cube, which will be a perfect cube. Hence, uh, 1536. The concept is that, so how do we actually find the least number that need to be divided to make it a perfect cube? So so you find the prime factorization, you do the prime factorization, you find the prime factors, and you have to arrange. You have to the one way is that you you write the prime factors, not the okay. So 1 5 1 1 5 1536. If we do the prime factorization, write it in terms of all the prime factors. We have 2 multiplied by 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 2. We have 9 2's. So multiplied by 2 multiplied by 2 multiplied by 2, and finally we have multiplied by 3. So this is the prime factorization of 1536. Now you form triplets of equal factors. So this is one triplet, this is one triplet, and this is one triplet. The factor 3 is left behind. The factor 3 is left behind. Whatever all the factors that are left behind, their product is the least number that need to be by which the given number need to be divided to make it a perfect cube. Therefore, least number by which 1536 is to be divided to make it a perfect cube is the product of all the factors which are not part of any triplets in the prime factorization of the given number. In the prime factorization of the number 1536, we see after forming the only factors which are not part of the triplet is 3. So it has to be divided by the least number that need to be by which 1536 needs to be divided is 3. And also you can see that 1536 when divided by 3, it becomes 2. We have 3 triplets of equal factors 2. So that is 2 cube multiplied by 2 cube multiplied by 2 cube multiplied by 2 cube, and we have the 3 and divided by 3. This is equal to 2 cube multiplied by 2 cube multiplied by 2 cube. This is equal to 2 multiplied by 2 multiplied by 2 whole cube. This is equal to 8 cube. So when 1536 is divided by 3, we get a perfect cube which is 8 cube. So 3 is the least number by which 1536 need to be divided to make it a perfect cube. So the correct choice is A. Okay, let's do problem number 9. We have to find what is the value of mixed fraction is given 1 and 3 by 10 whole cube. We have to find the cube of a mixed fraction. So we first need to convert the mixed fraction as an improper fraction. So this will be 10 plus 3 by 10 and whole cube. So this is equal to 13 by 10 whole cube. So now we have a cube of a rational number, and we know that the cube of a rational number x by y whole cube is nothing but the cube of the numerator divided by the cube of the denominator. So this will be 13 cube divided by 10 cube. Now what is 13 cube? Now, so this is the reason I don't know what is 13 cube. This is the reason you should be you should try to remember the cube and the squares of some two-digit numbers, like at least 10, 11, 12, and 13, and 14, and 15. Up to 15 is fine. And also the cubes of the single-digit number and their squares. So 13 cube, 13 into 13 is, I guess, 169. So 169 multiplied by again 13. I am doing it in a very straightforward way. So 27, 25, and I have 169. So this is 7, 9, 11, 2197. So this is 2197, and we have denominator 10 cube, which means 1000. Now this is an improper fraction. You have to, the choices are given as mixed fraction. You have to convert this into a mixed fraction, and it will be 2 and 197 by 1000. So the correct choice is C. C is the correct choice. Okay. The last problem is we have to find the cube of the decimal number, that is 0.8. We have to find the cube of 0.8. Now, to find the cube of decimal number, you first convert the decimal number to fraction. 0.8 is 8 by 10, and we have the cube. So now we have a cube of a rational number. The rational number or the fraction is 8 by 10. Now, okay, so 8 by 10. So this will be 8 cube divided by 10 cube. Now 8 cube we know is 512, and 10 cube is 1000. So this becomes, this is equal to 0.512. So the correct choice is C. So this brings to an end in solving the exercise 4D, which was 10 questions, which was all multiple choice questions based on the cubes and cube roots. Now it is highly recommended that certain things you have to be very used to. That is, first is to find the prime factorization of some numbers. It could be 3-digit number, 4-digit number, or even 5-digit number. That is super important. Then you have to also know the squares and cubes of definitely the single digit numbers, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, up to 9, 1 to 9. They are squares, they are cubes, and also squares and cubes of some 2-digit numbers like 10, 11, 12, 13, 14. If you remember them, if you practice them, if you write them down every now and then you will remember. This will help you in solving problems where you will ask to find whether a given number is a perfect cube or not. First of all, prime factorization is a must. It will be used everywhere. And while evaluating an expression where you are asked to find the cube root of some expression that has some perfect cube, you should be you should be able to promptly identify whether a number in any given expression is a perfect cube or not. It could be 3-digit number, 4-digit number, or even 5-digit number. So the next, there is a test paper, I think. Let me check. There is a test paper. Yes, there is a test paper 4, which I will solve in the next video. And once that is over, I will prepare 2 sample test papers on the chapter of cubes and cube roots. And also, please watch out my other playlist, that is Maths 8 Hot. That is where I come up with 10 good problems on each chapter. So since cubes and cube roots will be complete, I will start uploading and solving 10 good problems for on the chapter of cubes and cube roots in that playlist. That is Maths 8 Hot. Hot means higher order thinking problems. I hope this video was beneficial. If it is so, then please like it, share it with your friends, and also please once again support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. So thanks for watching, and until the next video, take care and bye.